In AV1-1, we're going to talk about the formulas for the areas of rectangles and parallelograms. So remember that the area is the number of square units enclosed by a plane figure. So if I have a rectangle like this, and I say, hey, this side is 5 and this side is 3, I have 15 squares there. Okay, so this would be 15 square units. When I'm looking at the area of a parallelogram or rectangle, I'm going to say that the area equals the base times the height. So A refers to area, B refers to length of base, and H refers to the height. To do an example, we're saying, hey, if the area of a rectangle is 96 centimeters squared, the base is 12 centimeters, we want to know what's the height. Our formula was just A equals B times H. I'm going to plug in the numbers I know. So A is 96. My base is 12. And I'm looking for my height. To get height by itself, I have to divide both sides by 12. And I do 96 divided by 12. You should get 8. On number 2, they're asking me what's the area of that hexagon. I'm going to split this into a few parts. I have this red rectangle. I have this green triangle, and I have this blue triangle. So the red rectangle is probably the easiest one to start with. This one is going to be 5 by 1, 2, 3, 4, 8. So that means this is 40 units squared. Looking at the blue triangle, if I cut this in half, this half is going to be the same as this piece would be. So instead of finding the triangle, because we might know that formula, but we don't know it quite yet technically, I'm going to look at this square instead. And this is 4 by 4, so 16 units squared. Same thing with this green triangle. If I take this piece and kind of imagine flipping it over and sticking it into this triangle, I get a 2 by 4 rectangle. So I have 8 units squared. Now I need to do some math, so I have 8 plus 40 plus 16. When you add all of that up, you should get 64 units squared. When I'm looking at my parallelogram, an altitude is going to be a line that is perpendicular to the base. It can lie inside or outside the figure. So in this drawing, this is my altitude. It's perpendicular to the base, but I could draw my altitude out here and be like, hey, that's perpendicular to the line the base is sitting on. I'm asked to draw a parallelogram and an altitude from one corner, okay? So if you're doing this on paper, it's going to look something like this. And then my altitude goes straight down. Make sure that it's exactly 90 degrees. If you cut right here and move that triangle over, you end up with a rectangle. So that means our formula for the area of a parallelogram is the same as it is for a rectangle, except my height has to be the altitude. It can't be that side x, okay? My base is still my base. In example 3, I'm asked to find the area of a parallelogram with base 25 and height 10. I'm going to draw a picture first. This base is 25. That height is 10. 25 times 10 equals 250 centimeters squared. Example 4, I'm asked to find the height of a parallelogram if the area is 7.13 meters and the base is 2.3. I'm going to think, okay, this is 2.3. I don't know my height, but I know that 7.13 has to equal 2.3 times h. To get h by itself, I'm going to divide by 2.3. And I get that 3.1 meters equals my height. Example 5 says, hey, the perimeter of a rectangle is 84 feet. The base is 12. We want to know the area. I'm going to start with a picture. This is my height. This is 12. I know in a rectangle, these sides are the same. So that also has to be 12. Which means if I subtract the two sides I know, I'm left with just what these two pieces have to add to be, which is 60, which means each half has to be 30. To find the area of a rectangle, I'm doing base times height. So 12 times 30 you should get 360. And we're in feet squared. If you need more help, this video kind of walks you through the same formulas that we're using in this homework assignment.